This video is about how to successfully study while taking Physics 211 and 212 online. I'd like to begin with two real stories from my student career. When I was an undergraduate student, I thought that I would like to add mathematics as a major in addition to my engineering physics major. So I took the Advanced Calculus course for math majors. At Michigan, this was the weed 'em out course for aspiring math majors. It was a brutal course. I failed the midterm exam. In fact, I flunked it miserably. Clearly, I was not destined to be a math major. So I requested permission for a late drop. The professor refused my request. He said something like, "I've seen you with your head down, taking notes furiously. You can't keep up. Nobody can keep up with me." This guy could fill the blackboards across the front of the room 3 times in a 50-minute period. Then he asked, "What do you do after class?" And I answered that I had a break and I went to a coffee shop down the street. He said, "Good. Don't take any more notes. Pay attention to what I say and watch me. Then go to the coffee shop and try to write out everything that I presented." I found that I could do it. If I had a little bit of a hang-up, I found that I could rederive what I didn't remember. I got an A on the final exam. There were only 2 A's out of the 50 students that took that exam. I never took notes again my entire life, not in any class or in any business meeting. I always went to my office and wrote down the meeting minutes from memory after the meeting. The second story is from when I was a graduate student. Every PhD candidate is required to pass a comprehensive exam prior to initiating dissertation work. At most universities, this is an anything-goes exam. It is typically 3 to 4 days of written exams and 2 one-hour oral sessions. Questions and problems are drawn from all physics subjects. Students usually study for 3 to 6 months to prepare. One day I was studying how electromagnetic radiation, radio waves, emanate from an antenna when I had an epiphany. The math was the same as the math that describes the angular distributions of particles emitted from nuclear reactions. Suddenly I realized that many apparently different physics subjects are actually the same, because they have the same mathematics. The immense subject of physics suddenly condensed to a small amount of principles and mathematics. Physics has been easy for me ever since that day. Studying physics is a discipline very different from studying any other subject. It is a very intense discipline that requires concentration and focus. Jack Nicklaus and Tiger Woods were not the greatest golfers of all time because they were physically dominant. They had exceptional ability to focus and concentrate. If you learn anything in this course, I hope that it is how to study and analyze. This video is about how to learn physics in an online course format. You begin by reading the textbook chapter from the beginning to the end. So here's the text, and you read through it. Your goal is to identify the concepts in the chapter and to see how they progress. Normally the chapter will start with a concept and then move through a chain of related concepts. For example, position leads to velocity, which leads to acceleration, which leads to methods of calculating trajectories. Physics is a problem-oriented subject. In real life, we pose problems based on our observations of natural phenomena, and we try to describe the phenomena with mathematical models. You learn to do this in physics courses by solving idealized problems using the mathematical connections to physical behaviors that are described in the textbook chapter. You have to learn to think like a physicist. In a conventional classroom format course, there are 3 ways that you are trained to do that. The first, and probably the most important one, is that you attend lectures where you watch a physicist think out loud in front of you, and you subconsciously emulate the lecturer as the semester progresses. The second is that the textbook chapters have examples and problems embedded in them with solutions to illustrate the concepts as you read. The third is that you try problems on your own. In this online course, we don't have a lecturer that you can emulate. Instead, there are some video example problem solutions, and you will find them here, video sample problems. And I'll pick this first one, and you can see that it plays. So in those, you will have slides presented, and the author will describe the problem solution orally to you, much like the lecturer does. And there are also, as you saw earlier, explorations, some of which include lectures that have been posted online by physicists teaching classes at various universities. Very popular ones are by Professor Lewin, who is retired from MIT. He's a very entertaining lecturer, and he presents material in a way that lets you see how he does it. After that, it is your turn. So you get out a pad of paper, a pencil or pen, and a calculator, which could just be a calculator on your computer. And you do practice interactive exercises, which you see down here. Now these are problems and questions to which you put in answers, and they have solutions and answers so that you can see how it's done. They'll tell you when you have it right, when you have it wrong, how it's done, and there'll often be one or more questions that go with the problems. And you can go back into the text while you're solving these and look things up as you do, and you go back and forth, and it's sort of a way of rereading the chapter, but this time with specific focus. The textbook can be a bit sketchy. It is sort of a giant outline for a classroom lecture format course. So I highly recommend that you read the material from Physics for the 21st Century Student that I will post in the announcements each week. It presents more in-depth explanations that a lecturer might present to augment the textbook material. I want to emphasize that this is not required material for the course. It is for your information only. So once you have done all of that, you should be pretty familiar with the material. Do the first 10 to 15 Orion questions. These are pretty short, multiple choice questions and problems, and you get immediate feedback about what you got right and what you got wrong, and you can view the correct answers when you get a problem wrong. Then go back into the reading materials to review the stuff that you got wrong and where you think you might be weak, and then finish the Orion. You need 30 questions to get a grade. Do 3 or 4 problems from the end of the chapter. Select ones that have the answers available and try to do them without looking back into the reading material. If you get hung up, go back into the reading material and maybe add another problem or two to your practice until you think you can do these things without looking in the book. The last step is to prepare for the quiz. The quizzes are timed. There is ample time if you know the material with confidence. You don't have to rush or feel pressured, and most of you will probably finish the test in half of the time limit. This is where you should remember my coffee shop experience. Make a quick review of the chapter and your problem work. Then put everything away and try to write down all the material in the chapter. Take a peek at the material if you get hung up, and then do it again. Keep it up until you can write out the material completely without peeking. Then you are ready for the quiz, when you can do everything from memory and you have just created notes that you can look at while taking the quiz if you have to. My experience is that you probably won't have to. So, the study process really comes down to this summary. 1. Read the chapter for the week. 2. Watch the sample solution videos and exploration videos. 3. Do the practice interactive exercises. Then expand the information by reading the matter from the Physics for the 21st Century Student. You don't have to do this. Do about a third of the Orion exercise. Reread the material where the Orion work suggests weakness, and then finish the Orion exercise. Do some of the problems with answers from the end of the chapter. Do the homework assignment. Practice writing down the material from memory, and then take the quiz. As the course proceeds, I will try to highlight the connections so that you see how the subject matter really condenses. That will be very helpful when you get to the final exam. I'll give you a hint. Motion along a line, which we call one-dimensional motion, is the same as motion around a circle. That is also one-dimensional motion. And so the equations are the same. But they are presented in the textbook in more than one chapter, as though they are different subjects. Have a good semester.